welcome to, I believe it's the 931st meeting of the Amateur Telescope Makers of Boston. I think for the first time, I might actually use the gavel to get us going. So,
Love it.
And I'm going to be happy to hand this off really quickly. So, welcome everyone. I'm really excited about this meeting. It's the last official meeting as me being president, so I'm pretty excited by that.
How are you going to pass the gavel?
We're going to have to do that in September, right? And hopefully we'll be doing that in Cambridge all together.
We all know that already. If the rarer the event, the more likely we have clouds. The saying I picked for this month, my amateur interest in astronomy brought out the term magnitude, which is used for the brightness of a star. And the quote was from Charles Richter, who developed the Richter scale of earthquake intensity, or magnitude. And I just found out over the years, I've got a couple of old AAVSO handbooks and newsletters. These are the stories of the AAVSO, and I was going through it, I saw his name, and he was a member of the AAVSO from 1914 to 1917. So he was in that organization for 4 years, and during that time, he made over 7,000 variable star estimates. So he was a serious member of the organization. We'll go on to the next slide. I want to thank Rich Nugent, by the way, for going over my notes. I sent it to him, and he found a couple of boo-boos. So hopefully we got this all straight this time around. Thanks, Rich. On Saturday, June 13th, in the morning sky, Neptune will be less than 2 degrees northwest of Mars. Look southeast at the time, and it'll be above and a little bit to the left at that time. The next day, it'll be just about above Mars. So if you have a low, a wide field eyepiece array, you'll be able to catch them both in the same field of view. On Friday, June 19th, a little bit before sunrise, Venus and the moon. Venus is now going to be in the morning sky, and they're both going to be thin crescents. They should appear together, look very low in the east-northeast, again about 30 minutes before sunrise. And there is going to be an occultation, but it's not going to be visible from here. It'll be visible in Canada, then across Greenland and the parts of Europe. So I would suspect that the two will be very close together from our location in the morning. So that might be worth a good view to catch them both, hopefully in the same low power field again. And you won't need high power. Venus, if you looked at Venus in recent weeks, even under 30 power, you can see that crescent very nicely. So it should be a nice sight together. Saturday, June 20th at 5:54 p.m. Eastern Daylight Time, summer solstice, which means the days get shorter again. That's tough news for a lot of people, great news for amateur astronomers. And on Saturday, June 27th, 2 hours plus or minus 9:36 p.m., the lunar X will be visible as well as the lunar V. So that's kind of a nice thing if you've never seen them before. They really stand out, and I'm amazing all the years that I've been looking at the moon. I never noticed that until somebody had mentioned it, and I went out that particular night and saw it, and it just jumped right out at me. And finally, on July 4th, and I always like this one, Earth at aphelion, and John Q. Public would have to think that we're the farthest, we're the closest to the sun on that date, but it's just the opposite. So while we're setting off firecrackers and celebrating, the Earth is the farthest from the sun as it can be. And again, I want to thank Rich, because I put perihelion down there and I had to change that. So Rich, thanks for that. But again, we're about, we'll be 94.5 million miles from the sun, versus around January 4th, we're 91.5 million miles. And of course, we're all astronomers, so you know it's because of the Earth's axis tilt. And in the wintertime, we're tilted away from the sun, so we don't get the direct rays. Next slide, we'll talk about the challenge of the month. And this one is a bear. I've talked to Rich about this one too. This is NGC 5689. It's a lenticular galaxy in the constellation Boötes, and it's a 12th magnitude galaxy. That's a lot fainter than a lot of the ones they've had before in the Observer's Challenge. I think back in January and February, we had a couple of 11th magnitude galaxies, which would be a little bit difficult. This one was really tough. You can see from the charts, it's actually located in the large chart there that shows Draco, Ursa Major, and so forth. You can see a cluster of 3 little stars, Theta, Kappa, and Iota, right in the upper corner of Boötes. And then there's a little black inset there. It shows a little close-up of that. And then when you go to the actual chart, the finder chart, and it'll show its location. And just what I found out, even knowing where to look, this was tough. I looked at it with my 10-inch reflector, and I saw it maybe 2 times with averted vision. And in both cases, I even needed to find a sweet spot. You know, averted vision sometimes doesn't work. You kind of have to look around, you'll find that sweet spot. And I saw just 2 pulsing glows on 2 different occasions in the correct spot. I did check later on, and I know I saw it, but very, very faint. So I think if you want to get a good view of this, you got to get out in the dark skies or use a bigger telescope. I think, let's see the next slide. I think that might be, oh, we get some photographs of it. Yes, next slide. Image from by Mario with his 32-inch scope. And Paul put in one too. Let's get the next slide there. And that's his image with a much smaller scope. And that's about it for this time. Again, as always, we ask you to keep looking up, and back to you, Tom. Thank you.
Thank you very much, Glenn. I really appreciate it. This is one of the favorite times of the meeting for me every month, is when you give the observers report. And now that I'm going to step down as president, I might actually be able to go out and try and find these things. So thank you very much. Appreciate the effort. Rich Nugent for the outreach report.
There we go. Well, good afternoon, everybody, or good evening, everybody. Before I get to the outreach report, I just wanted to mention a couple of other things for the observing report. Venus just passed through inferior conjunction on the 3rd of June. And as of today, by tomorrow, it'll be about 11 degrees away from the sun, now in the morning sky. And it's a perfect opportunity to try and find it in the daytime sky. I think what I might do in July is to give a brief talk about doing daytime observations. Venus is easy to find. By the beginning of July, first couple of weeks in July, it'll be at maximum brilliance, so you'll be able to see it with your naked eye if you know just where to look for it. And it's a fun little thing to observe. And at 13 degrees away from the sun, that's 26 solar diameters away from the sun. So it's in a relatively safe place to play around with your unfiltered telescope. I last saw it prior to inferior conjunction. I saw it 2 days before, and it was just a shade over 3 degrees away from the limb of the sun, which is a pretty treacherous region of the sky to be looking, but you have to be careful. But anyway, we'll talk about that next month. As far as outreach goes, yep, the situation, the status quo, we're without star parties for the foreseeable future. I don't know what's going to happen with schools in the fall. I doubt they're going to schedule any star parties where we show up, en masse with telescopes. But Corey and I ran, well, Corey did all the hard work. I just sort of sat there and chatted it up. We ran our, what I believe was ATMoB's first virtual star party for the folks over at the Farrington Nature Center over in Lincoln back on Saturday, May 2nd. And it was a pretty fun night. Mike Francis was Galileo for the first half hour. And then Corey took over with his part of the presentation. Could we do the next slide, Tom? Thanks. Corey's into electronically assisted astronomy, and he's got a robotic telescope, not a particularly large one, but he employs live stacking to produce real-time images that are remarkably, they're just incredible. We were at the clubhouse back a while in the wintertime, and he was showing us the live stacking with the Horsehead Nebula. And I've been looking for that thing for years, decades, naked eye, and I've never seen it. And this little telescope just brought that thing up on the screen in like just a few seconds.
And sometimes in color too.
And sometimes in color. So Corey's going to talk a little bit about that. And then before we ended, the other part of the presentation, we used the virtual sky programs. He used Stellarium. I like Sky Safari 6. And those are nice ways to, on a night where it's cloudy, or on a night where, like we had, where the sun had barely set, it gives you the opportunity to zoom around the sky. So Corey's going to mention some stuff about his robotic telescope. It's pretty cool. Listen up.
Sure. So we're hoping to use the EAA telescope, and I've got it set up so that basically the telescope, the camera, and the mount are all going into a small little mini computer.
Yeah, click the Corey.
And that mini computer's connected to a router so that I can drive it from my upstairs apartment. And it's on my computer screen, so it's really easy to share to Zoom, which we were hoping would be great, but the scheduling of the event, it wasn't quite dark enough to run it. But I think so that you can kind of see a basic overview of it, where I can either control it with a tablet or control it from a desktop. But I think on the next slide shows what we were hoping to do with it. You can kind of see on the left, there's the live stacking view, and you can see some galaxies in there. And the combination of really fast telescope and really low noise CMOS lets you get away with really short sub exposures. So it kind of, and with the computer live stacking, it kind of builds like a Polaroid right in front of your eyes. It's a lot of fun and pretty engaging. And then I also have a wide field scope to give kind of like a field of view. So on the bottom right, you can see the Big Dipper's bowl, and then the planetarium software up there. We can hop around, but unfortunately we weren't able to do the EAA, but we were able to run Stellarium and give kind of a virtual sky tour, which is a lot of fun. And it's free for everyone, so any of the kids could have sort of gone and tried it, downloaded it. We shared links with some resources on getting started.
We didn't have access to how many people were actually involved in the Star Party, but there were at least a few people were asking questions. And while Corey was running the software, I was trying to answer questions and talk about the things we were looking at. The nice thing about the virtual planetarium programs, and Tom, if you could click back, maybe 4 slides to the Pleiades, just to give you an idea of what you can actually see with, what you can show people with these telescopes. This is the one right before this is the one from Stellarium. That's what Stellarium presents when you zoom right in on it. And this is, of course, a free program. Sky Safari Pro, the next slide, is just a different version of it. There is a free version of Sky Safari. And the nice thing about it is you can tailor it to whatever you want to talk about. If you want to talk about something that happened in the past, the next slide shows Comet Hale-Bopp. And you can display that just as it was back in 1997. And the next slide shows the April 8th, 2024 eclipse of the sun, which you can show people. So these programs have the capability of going far into the past or far into the future, depending on what you want to show. And you can zoom in on these things, and most of them have nice little pictures to go with them. So when we can't use the live stacking, this is an opportunity to show people the sorts of things they would be looking at, and just have a running explanation to go with it.
Yeah.
Corey, was there more to show on your stuff?
Nope.
I didn't mean to
That's
back you
it.
up off of that.
No, and the great thing with like you said, Sky Safari and Stellarium, they're free, and anyone can jump in and poke around. So it's nice to show people easy way in.
Oh, there's your setup. That's nice.
Oh yeah, that's a non-crayon drawing of it. Yeah.
I was going to say you were getting pretty good with crayons. That's pretty good. Lots of time in the quarantine.
But you can see it's completely severed to the tablet. It's wireless. You could just as easily drive it from the desktop upstairs, which is fun.
And the nice thing about those planetarium programs is they'll actually control your telescope too. You can tell it where
it's
you want to
awesome.
point. So that makes it even that much easier. You don't have to be out at the telescope to run it.
Especially if we do get another sort of virtual Star Party, it's nice with the go-to for hopping around quickly to show people,
Yeah.
trying to entertain and keep interest.
And this may be
Could
the way
work out if they ever get the sky, time, and conditions to match up for another shot at it.
most of our Star Parties take place in the fall and in the springtime, not so much in the dead of winter, but March is a big month for Star Parties. And I know we cross into daylight savings time in March, but the fall is outstanding. And there are going to be some really nice things to look at this fall. Jupiter and Saturn, Mars, of course, is in opposition. Some of the outer planets are visible also. So if we don't run real Star Parties, this is certainly a way we can hold them without having to, while being socially distanced.
Yeah.
So good. I really thank Corey a lot for helping out with that Star Party because
I thank you, Rich. It really bailed me out. I was trying to do some other software and it just wasn't working. Rich was able to keep the crowds
entertained
engaged and discussed.
Yeah.
Talking about things. And
Yeah, it went pretty well, I thought. All right. Well, I guess that's it for outreach. Thanks, Corey. Thanks, everybody.
Thanks a lot, guys. Really appreciate it. With that said, our featured speaker is Alan Sliski. He was very gracious in accepting my invitation to speak. I think it's going to be a really fascinating talk, and I might say that he's asked, people have questions throughout the talk. He's encouraging that. before we go any further, his topic is going to be on the design and construction of an automated observatory. And Alan has been interested in mechanics and electronics from a very young age. And he built his first tube amplifier in 6th grade. So it suggests that he built more than one tube amplifier there. But he's been very much into astronomy. He holds a number of patents in his name after graduating from the University of Amherst in 1978. And for the last 30 years, he's designed medical equipment for treating cancer with radiation. More recently, he's been getting involved in astronomy at home with his 2 sons interested in astronomy. He has a reasonable collection of modern telescopes, from an 80 millimeter to a C14, but is also the president of the Antique Telescope Society and also hosts informal meetings of local antique telescope collectors. I'm going to skip on, but he maintains a complete workshop and lab, and you might see that in the background as he was speaking at his home for projects such as this. So with no further ado, I'd like to introduce Alan Sliski, and I will stop sharing.
About 8 years ago, I was asked to help design a new observatory for an ATMoB member in Dover, Massachusetts, a fellow by the name of David Middleman. You can see him standing in the doorway of the observatory there. Anyway, he had progressed from a few simple telescopes to wanting something more. And unlike most amateur astronomers, he was not budget constrained. So he asked for a lot of help, and we, myself and a number of other members, including my 2 sons, John Briggs, actually John Small, helped with the observatory. Anyway, we built him a new observatory to go on his roof of his house in Dover, Mass. So this is a picture of us when we finally got it on the roof. So the mission we were given was to make a very flexible, comprehensive, modern automated observatory that would fit within the space of the roof. He had a flat piece of the roof with a railing around it, and we had to work within that. So it wound up about a 7-foot cube. This is a photo of one of the intermediate conditions with refractors on both sides and cameras and filter wheels. The main instrument's a Planewave 17, but we started with the basics, the structure of the house, did a SolidWorks model, and tried to figure out what we could fit in the building. And Planewave makes 4 telescopes in this series from 14 to 24 inches. And we thought we'd start with a bigger one, and then we found out it really wouldn't fit. So we settled on a 17-inch on a Paramount ME, and that kind of fit. It's a tight fit in that it's not a good observatory for visual use because there's no room for the people while the telescope is in action. So why automate? Why would you create an automated observatory? So the telescope stays outdoors basically, and the people stay indoors. And you get to go to sleep. And the telescopes works all night if it's clear out. And the warm room can be nearby or anywhere in the world, actually. His study was 2 floors down, and you can also allow other people to use your system by creating scripts to, you basically generate a list of targets with exposure times and filter settings. And then the telescope works all night, and you get a message in the morning that says you have pictures. So if anybody's interested a little bit about how this works, there's some nice YouTube videos on this product called ACP. This fellow named Bob Denny out in Arizona that wrote this very interesting software. Dennis DeChico has an interview with him at a previous NEAF meeting. And so it might be worthwhile to get a little talk about that at some point later for the club, because it's a way to really magnify the use of your observatory for off hours. You know, when you'd rather be sleeping, the machines can still be working for you. So you want to do some system planning. You want to just define the type of observing, whether you want to do planetary imaging, whether you're in the what many people call the pretty pictures mode, where you're trying to get a picture of some wonderful phenomenon in the sky, and you want to get on the astronomy photo of the day website with some really cool thing, or whether you want to do science, you want to do photometry, or anyway, there are a few different directions you can take that vary some of the equipment choices. Much of it's the same, but you know, like the camera and the filters, you might choose different things depending on your interest. So you'd make a block diagram of your system. You choose the equipment wisely with a mind toward connectivity. This is important because the amateur astronomy market is comprised of dozens of small companies, and their software skills are variable. Some of them do a good job, and some of them not so good. And so you're trying to get, whenever you're doing automation of hardware, there's a lot of difficulty involved with, you know, drivers and getting different systems to speak together. This has been helped a lot by what's called ASCOM, which is a communication standard, but it still can be difficult. And then you got to consider all the other accessories. You need to set the system up for unattended operation, you know, flat field panels, weather sensors, things like that. This is the block diagram I made, and it gets busy, but this allows you to plan for how many outlets you need, how many wires go through the mount, how things interact with each other. And it's worth doing, even if you have a simple system. You saw the early presentation, you had a little cartoon sketch of how things are hooked together. That's important to do so that you can understand how, you know, like in the middle, there's a outlet strip. And right now I got 1, 2, 3, 4, 5, 6, 7, 8. I got 9 outlets used. Well, maybe it only has 8. And you need to start thinking about that. If you want to do a professional job, neat job. Observatories tend to be located in places that are prone to lightning. They tend to be on top of hills for optical reasons, but that also tends to be a target for lightning. This is a tree that was struck by lightning out at Oak Ridge Observatory in Harvard. A lightning bolt, which was called, this particular lightning was what's called a positive strike. It came from the top of the cloud, 50,000 feet, came down in the woods, and this is one of 2 trees that the sides were blown off. The lightning hits the tree, it turns the tree to steam, and the steam pressure explodes the tree. So it basically turns the half of the tree into toothpicks. And there was another one about 50 feet away that got the same treatment. So the lightning bolt from this got into the ground, found an old piece of barbed wire, and exploded that. So it literally dug a trench through the woods for about 100 feet. It went under the road at the observatory, blew a chunk of the asphalt out on the way. and then got into the main conduit that ran between the radio observatory and the observatory, and then went off and raised hell. The computers at the observatory, the lightning got into, and when they took them apart to look inside, all of the chips on the motherboards had little craters where the silicon used to be, where the chips used to be. So you want to plan for lightning protection. So you want to have galvanically isolated things. Serial ports are bad, USB ports are bad. Ethernet's actually pretty good, and Wi-Fi is even better. So I actually set up a Wi-Fi router on the back of the telescope that was set up in bridge mode. It talked to another identical router on the wall of the observatory. So the only thing coming through the mount was the power cord for this outlet strip. And that saved us a lot of trouble. So we have the Wi-Fi routers in bridge mode. It behaves like an Ethernet cable. It gets rid of all the dangling wires. All the dangling wires from the cameras and everything get wrapped up when you slew around the sky. And it gets the computer out of the path of the lightning. One of the things we had to do was create a structural floor for this observatory sitting on the roof, because couldn't just sort of plunk it down. So the observatory had been put on the roof as a temporary sort of thing, and it was not stable enough at all. So we actually took it down, and while we were doing that, David Middleman actually had the whole roof structure re-engineered with some I-beams to hold the observatory. The roof had a few leaks anyway. It was due. But in any event, I went down to a fabricator in Springfield, Mass, and they built this framework for the structural floor, and then welded 1/4-inch aluminum top and bottom. So this is now the floor of the observatory. You can see my son Aaron over here visiting. And you notice a couple of holes here. There's a piece of conduit that runs from under the pier out to the wall of the observatory, so we don't have wires dangling on the floor. And you can see that in this view. There's a conduit under the floor, comes up over here. So this is a 4-post elevating pier. I had my son Aaron, who's getting a little better at wiring things. I had him to try to do a very neat job, and he did, of putting in self-adhesive LED strip light. And we did white and red for obvious reasons. And a 4-post elevating pier means that you can open the roof and then get the telescope up above the wall so you can see the horizon. And you have to interlock the elevating pier, the roof, and the telescope, so that the telescope has to be parked before the roof will move. The roof has to be open before the pier will lift. And you have to have everything in the right sequence, because you don't want the telescope going up through the roof, because the software had a bug. The equipment on the telescope mount evolved over time, and this is one of the configurations along the way. So there's a 17-inch plane wave in the middle. You can't hardly see a telescope. Filter wheel camera, focuser, and then there's a 4-inch refractor over here, electronic focuser, camera, and another refractor on this side with a camera. So, but you'll notice there's no wires hanging off the thing. All the signals are translated to Wi-Fi to this router here, and they communicate to another unit on the wall. A Ethernet controlled power strip is a really good idea, because you can turn things on and off and reset stuff. System integration and testing. This is a very complicated rig. I had my lab I was renting in Bedford. I had space to bring the whole building inside and work on it in a controlled environment next to all my machine tools, and electronic shop and bench space. And it turned out to be much handier than I had anticipated, because there's any number of little things that need adjusting along the way. And to have the machine shop right next to the building helps a lot. So here we could set up the telescope with the focuser, filter, wheel, camera, everything on the bench. And because it's Wi-Fi, I could talk to the computer in the next room where we were doing all the software installation. The plane wave focal reducer was like 2,000ths oversized. It wouldn't actually fit, so I actually had to machine down the lens holder. I had to take about 2,000ths off to get it to fit. Now, we could have stopped what we were doing and sent it back to plane wave and got another one, but that would have been like a week cycle time. John Briggs was helping us, and he helped facilitate the project as well. And there we are, putting the telescope on the mount for the first time. And here's my son Aaron on the left, David Middleman, who envisioned all of this, and myself getting it all together. There's an interesting story at this stage. The first time we put it on, there's a quirk about the exact method how these plane wave dovetails clamp together. When you put the telescope and you tighten the screws, there's a way to get the telescope slightly cocked. So when you tighten the screws, even though everybody's being extremely careful, the telescope's not in the right place. And it's possible when you swing it around for it to shift and loosen up and actually slide out of the dovetail. And that happened to us. My son happened to be standing right here when the telescope slid out of the dovetail, and he caught it. So he was christened Scope Catcher at that point. So here's my son Aaron, John Briggs, David Middleman, and the things starting to come together. The pier's on the ground, the mount is on the pier, the telescope's on the mount, and everything's starting to come together. This is what the roof controller looks like. I made a new illuminated push button setup so you could find it in the dark. This is the other end of the Wi-Fi router that gets all the communications from the telescope. And the lighting controllers are up in the corner here. So we had to get this from the shop in Bedford back onto the roof in Dover. So I took it out with my forklift. John Briggs carried the telescope. We put the telescope back in the crate. And then we rented a car carrier flatbed to bring it over to Dover, and hired a crane to put it back on the roof. So there was a crane to bring it down, a crane to bring it back up. We put the telescope in the observatory for the ride with the crane, because carrying this up stairs, 3 flights of stairs through a little hatch, was less desirable. This is where it's going to land. I had designed, these are stainless steel pipes that rest on the I-beam below, and there's threaded rods that come up through that. So the observatory rests on top of these stainless steel pipes, and these threaded rods go up through holes in the floor, and then nuts go on there. So the threaded rod hold the observatory down in the wind. And we needed a pretty long crane. It's a 50-ton crane with the jib on, and that was basically to get the reach. The observatory itself is maybe 1,500 pounds. It's not that particularly heavy. We had to reach underneath to guide the threaded rods up through the holes, but it all worked extremely well. And unlike most telescope projects, it was actually clear the night that we got it together. And because we had done all the testing and integration ahead of time, all the software installation, he was able to use this that night. It's quite remarkable. Usually you get cloudy weather for at least a week per inch of aperture. So Then we started adding more things. We found out that these are the tracks for the rolling roof. It acts like a big drawer slide, but the top of these get covered with ice in the winter and it won't move. So I made these ice shields to keep the weather off of the tracks. And then we said, well, that's a good place for an all-sky camera and a Boltwood weather sensor and a Davis weather station.